Hello, welcome back to CS232. Today we're going to be talking about switch statements and loops. So I also wanted to remind you to finish the labs for week 5, part 1, and part 2 for the first lab, which is the try it out exercise of Whitaker on page 63, and also the try it out section on page 65. So you've got 2 parts of that one lab to do, and you can hand that in on Dropbox under week 5, lab 1. So now we're moving on to switch statements. Switch statements are basically an alternative to if-else. Pretty basic. Basically, so often we want to do an if statement where we say if something is true, then do this thing. Otherwise, do something else. Otherwise, do something else, so on and so forth. For example, remember back to our previous slides, we had that long if-else statement for, actually I'll bring up Xamarin here to show you what I'm talking about here. We had this long sort of switch statement to, or this long if-else statement to account for what a score was. We could easily kind of wrap this into a switch statement, which is what we're going to be talking about next. So probably a better example actually of switch statements is, for example, a menuing system in a game. It's a pretty common thing to do. It's also pretty common to have a variable, and we're going to do a few different things with that variable depending on what the value is. So if you consider a menu system, like any menu system you want, even the Windows menu system, for example, you press the Windows button and something comes up, and then you could press documents, or you could press pictures, or music, or games, or favorites. Each one of those is probably represented by a number somewhere, and that number will eventually open the thing that you want in Windows. It's the exact same kind of concept on the menu of a game, for example. And in this case, we could do this as an if-else structure. We could say if menu choice equals 1, then you choose option 1. Else if menu choice equals 2, you choose option 2. Else if, and so on and so forth. However, it looks a lot better if we do this as a switch. So in this case, the thing that we're doing the if check on, note that in every case it's menu choice. Menu choice, menu choice, menu choice, menu choice. We're repeating that all over the place. In a switch statement, you just say it once. So it's basically if menu choice is 1, if menu choice is 2, if menu choice is 3. Each one of these is a separate if-else statement. So this is a if, then do this. Else if it's 2, do this. Else if it's 3, do this. And switch statements require this break in here, which we'll talk about in a little bit. They also require you to say switch, and then what the menu choice is, and then what the value is for each one of these tests. So if it tests to be 1, then we say console right line, you choose option 1, and there's actually a typo here I'm going to fix really quick. There should be an I in there. So if the menu choice is 1, then it does this. If it's 2, then it does this. Now the default is actually, if it's none of these, then it does this. So for example, if the case is 6, it would say, hey, that wasn't even an option on my menu, and it's going to break in that case. So this kind of looks a lot better than that huge if-else chain. And you can think of that default as the final else. Basically, if you've got an if-else chain, it was always if, else if, else if, else, similar to what we saw when we were looking at the Xamarin case, if, else if, else if, else if, else. Also, only exactly one of these cases will ever be executed, so the switch guarantees this. In C#, we're required to put the break keyword at the end of each case statement. So we're required to put a break here, a break here, a break here. Basically, anytime you do something inside of a case, you're required to put the break keyword. And that ensures in C# that exactly one of the cases will ever be executed. So you can't use custom objects in uh, inside of switches. However, you can use bools, strings, and any of the integral types of C#, for example, char and int. So that means that we're allowed to use bool, we're allowed to use char, we're allowed to use int. So if you did have a custom object, I suppose you could have a function, well, a method rather, that returns a bool, and you could switch on that, and that's quite common. So you could say, like, is score, is level complete, for example, could be the name of your method, and that could be a bool that returns, and you could switch on that. And if it's false, do one thing. If it's true, do something else. There's a special case switch, in which case you don't have to put a break in it. This is the one case where you don't have to. And in this case, we just say case 1 and case 2. So both case 1 and case 2 are going to execute this code here, which says console write line. You choose option 1 or option 2. In C#, that's the only time where you don't have to write a break. And basically, think of it as flowing through to this line. So case 1 follows case 2, and we write line, choose option 1 or 2. Okay, so the next topic that we're going to cover is looping. Looping is a pretty fundamental concept to programming. It allows for sections of code to be repeated over and over, as long as something's true. It's also called iteration. And we have while loops, we have do while, and we have normal for loops. Just on a whim here, I'm going to do something really quick. Let's say we wanted to run this. I'm just going to randomly decide to do something here. Enter your score, or -1 to quit. So basically, this is going to say, enter my score, or if I type in a -1, I'll quit. And then I can say while. So this will allow us to keep going forever. While score not equal to -1. So we're going to keep doing this forever. And it'll tabinate it for us nicely there. I have to set the score because I'm going to use it right away. I'm just going to set it to 100 because I'm going to overwrite that right away. So this just basically, and with those simple changes, I can run this now. It asks me to enter my score, or -1 to quit. 40, I got an F. And it runs again. 60, I got a D. It runs again, 84. Now if I hit -1, it's going to say F. So I need to code up that possibility, which is very easy to do. And you'll notice that this basically, it allowed me to exit as soon as score was -1, but I also don't want it to print out what the that I got an F in that case. So one thing I can do to solve that is I can say if score is equals -1, break. And we'll talk about this shortly in the slides as well. Break exits our while loop, and we can do it as such. I'm just going to test this again. It's always a good idea to test your changes, even if they're seemingly simple. Enter 85, -1, press any key to continue. That's what we want. Now, actually, we can do this. We can say while true, because what break is going to do is it's going to break out of whatever the current loop is. Well, the current loop is while. So this is going to run forever until the score is equal to -1. So we can do that. And we're going to say 75, C, -1, press any key to continue. So it operates exactly the same. So just going over those concepts quickly, I just want to show you in Xamarin. Now if we go over those concepts, what we're really doing is we're doing something called iteration here. We're repeating over and over a section of code as long as this, so this is kind of a little bit confusing at first, but basically as long as score is not equal to -1, we're going to continue. So score starts out at 100, then we get in here and it reads it, it sets it, and if it is -1 it breaks, otherwise it keeps going, and then it checks the score again. So in that first case it was 75, 75 is not -1, so it's going to read it again and do it all over again. That's what we call iteration. And there's 3 types of loops. We have while, do while, and for loops. So while loops are the most generic of the loops. They do something as long as some other thing is true. So while condition, and this can be any of our Boolean valued conditions. You could use ampersand, ampersand in here for an and, or pipe, pipe for or just a simple unary, one Boolean expression in there, and that would work. And that condition, this code will be repeated as long as that condition is true. So here's an example that will write out the numbers starting at 1, and it will write up to 11, because it says, well, x is less than or equal to 10, write it out. So it comes in here, and it writes it out. It writes out 2, it writes out 3. Now once it gets to 10, it's still less than or equal to 10. So it writes out 10, and now it's 11, and so it will not write out 11. So in other words, it starts at 1, it evaluates if x is less than or equal to 10. Since it is less than or equal to, it goes in, 1 is printed to the screen, x is then set to x plus 1, so x is now 2. And it evaluates if x is less than 10, which it is. It goes to the next branch, and we print 2 to the screen. This continues until x is equal to -11, at which point it's printed every integer value up to and including 10. Now, I showed you this already. This is an easy way to make an infinite loop. So say while true, and it'll never end. So, for example, if I go back to Xamarin, and I take this out, this break statement, and then I say while true, this is going to go on forever and ever. And this is kind of a way to demonstrate how you can write infinite loops. This is going to say, 90, 80, 85. Even if I say -1, it's going to say I got an F, but then it's going to continue on, which is not what we want. So I'm going to just Control-Z over that stuff. Get back. So that's an infinite loop. And basically, anytime you write a while loop, you got to be aware that if it evaluates to true, it's going in there. So you want to pick something that's eventually someday going to equal false. You want to think of the case in which it's going to be false, and know that it's going to end when it's going to be false. Otherwise, you've got an infinite loop. So think about that every time you write a loop. Like, what's the ending condition? In this case, the ending condition was that it is 11 or higher. In other words, that it's not less than or equal to 10. So the user, or whoever wrote this, knew that they wanted to write the numbers 1 through 10. In our case, we knew that we wanted to enter the -1 to exit our little scoring application, and then that's when the while loop would exit. Otherwise, it would continue. A lot of people use it kind of like I showed you there. It's a way of making sure that valid input is given. So for example, if we're looking for a player number, say in a multiplayer game, and we want to make sure that that player number is valid, say it's 0 through 10 is valid, we can say while player number less than 0 or player number greater than 10. So in other words, while the player is entering a negative, while the user is entering a -1 or 11 or higher, -1 or lower or 11 or higher, we say no, that's not a number between 0 and 10, so keep reading it. So do a console.readline, convert that to an int, try again, and keep doing it. That's what we call input checking, and that's a very common way to use a while loop, and it's something you can use in your assignments. Now the do while is very similar to while, but it's kind of upside down. It always does the code at least once, then checks the conditional, whereas in a while loop, it checks this conditional first and only executes the code if this while loop is true. Do while always, no matter what, does this code, and then checks the conditional in order to see if it should do it again. So do while is useful if there's the first thing you want to do. For example, in this case, you know that the player number doesn't have to be set outside the loop for this to work. So we just have player number in here, and the player number isn't set to anything until the player actually does it, and then we check to see if it's a valid player number, and if it isn't, we come back in. So we always want to, the writers of this code knew that we would always want to essentially get the first input from the user, and perhaps we'd want to get a second, a third, a fourth, but we always knew we'd want to get at least one input from the player. Personally, I use for loops the most. I use a for because it's convenient. It packages everything into one nice little trinity here of three different things. One is for setting the iterating variable, in which case this is x. It has a conditional, x less than or equal to 10, and has what to increase by, x plus plus. So it does everything in one line, one nice little line. So when we come in here, it says for int x. Okay, so I'm going to initiate x to be 1. And then x is going to be valid in this entire for context, in this entire for block. We check if x is less than or equal to 10. And then we do a write line, x. And then the third thing we do is we iterate on x. We say x plus plus, so x ends up becoming 2 on the next run through. So this code does exactly the same thing as the code you saw over here. It's exactly the same, except in this case it initializes the x for us. The for loop also plus pluses on the x right before it goes into the next loop. So it was found that people do this kind of thing. They do this kind of thing here so often that they made this idea of a for loop, and it's really handy. So the way I think of it is, first it initializes, then it checks, then it does its code, then thirdly and lastly it iterates the number. Now this particular one is going to skip, this continue that we're looking at was going to skip the 3. We'll look at that in a second. I need to back up. So we already showed the break. I did something very similar to what Whitaker is showing, where it says, what is thy bidding, my master? It does a string input console read line, and it forces a quit only if the input is quit or exit. Otherwise, presumably, it's going to do something else. Actually, the truth is, most games work like this. They'll have an outer while loop that just runs the game loop forever until some menu system says break out of that loop and end the application. So a lot of applications work like this. Likewise, there's this idea of a continue. A continue is like a break, except it doesn't break the loop. It just continues to the next iteration of the loop. For example, this one, it says if x is equal to 3, then continue. That runs in the for loop, that runs the iteration thing, x plus plus, and then it continues. If you do a continue in a while, you would need to update the x first and then do the continue, because of course there isn't an automatic iteration application like there is in a for loop. Now, nested loops are something we do all the time in code. Let's say we wanted to print out a bunch of rows of things, all of a certain length. In this case, we're printing out a bunch of stars, all of length, what is this, of length 9. So we're printing out 5 rows of 9 stars. This suggests a loop, but you have to have a loop inside of a loop. So we go from row 0 to 5, so that's 0, 1, 2, 3, and 4, so that's 5 rows total. We go from 0 to 10, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And for each of those, we write a star. And then we write a line to wrap it around to the beginning. The write line, just like this, all alone, just causes a carriage return to happen. So we do that at the end of every one of these rows being written. Then we do a write line to get us to the next row, do it over again, and go from there. And that's about it for loops and for switch statements, and I think you guys should have enough to go on for the assignment and the quiz, so good luck on that.